Hello and welcome to all in this video lecture series on 8051 microcontroller. We are discussing a hardware interfacing with 8051 microcontroller, and in this video session we are going to talk about LCD interfacing with 8051 microcontroller. In previous video session we had discussion on how to interface this LCD with 8051 microcontroller in 8-bit mode. In this video we are going to talk about this LCD operation in 4-bit mode. In short, how to interface the LCD with 8051 microcontroller in 4-bit mode, right? So as the name suggests, in 4-bit mode, whatever data or command that given to the LCD is sent in 4 bits only. That means in a 4-bit format. To do this, first send the higher 4 bits of your data or command and then send the lower 4 bits of the data or command. And as out of 8, that is from D0 to D7, only 4, that is D4 to D7, these pins of the LCDs are utilized, right? So here, and the next other control pin, that is RES, R/W bar and EN are connected to the other GPIO of 8051 microcontroller. So the biggest advantage of this 4-bit mode is that, right, due to such connection we can save the 4 GPIO pins of 8051 microcontroller, and these remaining 4 GPIO port pins can be utilized for another application, because in 8-bit mode we have seen, right, whatever the 8 bits are there, that is D0 to D7, these are connected to the any port pin, right? Say suppose I am going to say as a port say simple PM, right? So what will happen, this D0 to D7, suppose I am going to deal with a port P3, then from P3.0 to P3.7, means all these 8 port pins are engaged to transfer the data as well as command to LCD. In short, for 8-bit mode, all the 8 bits of all the 8 GPIO port pins of 8051 microcontroller are engaged. However, the same task can be done by using only the 4 bits of LCD, and hence out of 8 we are going to make use of only 4 GPIO port pins of 8051 microcontroller. And here these two collectively commands we are going to use in order to enable the 4-bit mode for LCD. Okay, so here it is the connection, right? So the diagram gives us a difference here, right? When I am going to talk about the 8-bit mode, all the D0 to D7 are connected to microcontroller, whereas in 4-bit mode, right, only higher 4 bits, that is from D4, D5, D6, D7, only these 4 bits or data lines, I can say, of LCD are utilized for the data transmission, right? So here this diagram gives us the better differentiation. In 8-bit mode, all these 8 bits are utilized, all the 8 bits of LCD are utilized to transfer the data or command to LCD from this 8051 microcontroller, and as all the 8 pins are utilized, right, here all the 8 GPIO port pins associated with port P3 are engaged for the data transmission or displaying the content on this LCD, or in short in LCD interfacing. However, when we talk about the 4-bit mode, only 4 bits are utilized of this LCD, and hence we are going to make use of P3.4 to P3.7 only, and whatever remaining 4 are there, that is P3.0 to P3.3, these 4 can be used for another application. In this way we are going to enhance the capability, the operational capability of 8051 microcontroller by using the remaining 4 port pins for the another application, right? Let us consider one simple example. Write an embedded C program to display string DKTE-TEI to first row on LCD in 4-bit mode, and the connections RES should be connected to P2.0, R/W bar should be connected to P2.1, and EN should be connected to this P2.2, right? And the data lines, okay, so here instead of using D0 to D7, the D4 to D7 should be connected to P3.4 to P3.7, right? So this is the connection that we have to follow, and in accordance with this, my interfacing diagram may be look like in this way. The RS pin of LCD is connected to P2.0, R/W bar is connected to P2.1, and EN is connected to P2.2, right? And here, as it is a 4-bit mode, only higher 4 bits of data line are connected to higher 4 bits of port P3. Okay, so in this way, right? So as we know that when I am dealing with the LCD interfacing, the first task that we have to do is what? Do port programming. Okay, do this port programming. Okay, so in order to do the port programming, what we are going to do here, the control signals are sent from my is configured as output, and also the data or command is given to LCD through port P3. So the port P3 is also configured as an output. Okay, then the second one, what is that? We have to send the appropriate command, right? So in order to send the command, first of all, what we are going to do, whatever the contents are there, just send this content on data line, right? Send the command on data line. Then second, select the command register. So I am going to make this by making RS is equal to 0. So to avoid confusion, instead of using select, I will write make the RS pin equal to 0. So what will happen? The moment at which we are going to make the RS pin is equal to 0, command register is selected, and as the command register is selected, the data present on data line, right, is treated as a command, and it is used for the configuring the LCD, right? The third one is what? Make simple R/W bar is equal to 0. That means as we are dealing with the writing operation, and then enable this LCD. How we are going to enable this? Make EN bit is equal to 1, introduce some delay, and again make this EN bit equal to 0, right? So these are the steps that we have to follow. Then once I am going to send the appropriate commands, the later stage, what we are supposed to do, we have to send a data. Okay, so what is that? Send data. And in order to send the data, what we are going to do? Simple as usual. Okay, copy the data on data line, right? This is the first stage. Then second, make RS pin is equal to 1. So what will happen when I am going to make the RS is equal to 1? Data register is selected. That means the data present on the data line is treated as a data, and it is displayed as it is on the LCD panel. Then LCD. How we are going to enable it? Make EN is equal to 1, give some delay, and again make this EN is equal to 0. So these are the steps that we have to follow when we are going to interface the LCD with 8051 microcontroller. Now the most important one, how exactly transfer the data to this 805 from 8051 microcontroller to LCD. So let us check out that. Okay, fine. So in 8-bit mode, what we did, see here, this is D4 to D7. Okay, in 8-bit mode, all the 8 data lines are utilized, that is from D0 to D7, and these are connected to P3.0 to P3.7. And actual either data or command, whatever we are going to transfer, that is there into 8 bits, and all these 8 bits are transferred simultaneously. It is done where? It is done into the 8-bit mode of the LCD, right? A simple and straightforward. Now when we are going to talk about a 4-bit mode, in 4-bit mode, what is there? We are going to utilize only D4 to D7, that is higher 4 bits of data lines, that is higher 4 data lines, and then we are going to utilize the higher 4 GPIO pins of port P3, right, in this way. So what change is required here? Again, whatever the data or command that we are going to transfer, it is there into 8 bit. But now these 8 bits we have to transfer in such a way that first let us transfer the higher 4 bit and then transfer the lower 4 bit, right? Then how to do the same, right? So let us consider I am going to transfer the first command, right? And suppose that command is my 0x28. This command I am supposed to send to this LCD. Then how we are going to do this? Suppose x is equal to 0x28. So first of all, we have to transfer only the upper 4 bits, right, and then the lower 4 bits. So I will say it is 0 0 1 0 and then 1 0 0 0. This is the command that we are supposed to transfer to this LCD. So what we will do? First, I am going to mask the lower 4 bits, right? So for that, I am going to do the ANDing, right? So what will be my next step? X is equal to x is ANDed with 0xf0. So what will happen? It is 0 0 1 0 1 0 0 0 and it is ANDed with 1 1 1 1 0 0 0 0. And what is my result? I am getting the result as 0 0 1 0 0 0 0 0. So what is this? This is simple my 0x20. Okay, and now just forward this data to the port P3, right? So here I am going to write P3 is equal to x. So what will happen? As the lower 4 port pins of port P3 are unconnected, so this 0 is not considered or it is not having any effect on the LCD operation. However, only higher 4 bits are forwarded to LCD. Means now in first single stroke I am going to send the higher 4 bits here. That is what simple my 0 0 1 0, right? Now next the lower 4 bits also we have to transfer. Then what I will do? Simple x is equal to x is shifted to left by 4 digits, right? So what will happen? Initially it is 1 0 0 1 0 1 1 1 sorry 1 0 0 0. That is what it is a 28. Now it is shifted to left by 4 digits. Okay, so because of that it is 1 0 0 0 0 0 0 0. So in the second stroke I am going to get a value that is 0x80, and this data again I am going to transfer on port P3. But as only upper 4 bits are connected to the data lines, upper 4 GPIO port pins are connected to data line, only this 8 value that is 1000 is transferred to the LCD. So in this way we are going to transfer any data or any command to this LCD from 8051 microcontroller. To step I can compress together or club together in this way. P3 is equal to x is ANDed with 0 x f0, right? So what will happen here? First, as it is an assignment operator, the first of all the rightmost part is get evaluated. So what will happen? P3 is equal to simple 0 0 1 0 1 1 1 sorry 1 0 0 0, that is 28, is ANDed with 1 1 1 1 0 0 0 0. So what is the resultant of this entire value? First it is 0 0 1 0 then 0 0 0 0, and this value is now get assigned to P3, right? So first I am going to transfer this data. Then again as usual what to do? Just make rs is equal to 0 to transfer the command, or if it is data then rs is equal to 1, make r/w bar pin is equal to 0 and just en is equal to 1, then delay and again en is equal to 0. And after this again x is equal to x shifted to left by 4, right? And then P3 is equal to x ANDed with 0xf0. So what will happen? Ultimately 0x80 is transferred or forwarded to this LCD, right? So let us check this discussion with one simple program execution. Okay, so here Now I'm using here as in the shown in the diagram, the port P3 is connected to the data lines of LCD, which is going to work as output for 8051 microcontroller. The OP label, that is output label, OP represents here as output. The OP label is assigned to P3. RS label assigned to P2.0, RW assigned to P2.1, EN assigned to P2.2. In the sense, these three port pins are connected to the RS pin of LCD, R/W bar pin of LCD, and EN pin of LCD respectively. To send command, the CMND routine is there with me, or the function is there with me to send the data, DAT function that I have written, and to introduce a delay, the delay function is there with us. Right? So now here, which what we call the data we have to display, it's a DKT, right? DKT DEI. So I'm going to define this as my string. So first of all, OP is equal to 0x00. So what will happen? The port P3 is going to work as a output. After that, send 02 command, 08 command, 0E, 06 and 80. So sequentially I am going to transfer all these commands here, right? So just now pay attention. So what we did, now I am going to first say transfer 0x02. Now as I am going to calling this command routine, the value of x initial phase, it is going to hold the value 02, right? So now the 02 is ANDed with F0. So the result what I am getting, simple 0, right? And the 0 is now sent on the port P3. So I will say only upper 4 bits are first forwarded to this port P3. Then just shift the value of x to left by 4, right? And in order to do the same, I am writing x is equal to x shifted to left by 4 digits. So now the value of x is what? It's a 20, right? And out of this, when I'm going to AND it together, I'm getting the result as a 20, and only upper 4 bits are again forwarded to port P3. So in this way, whatever the 8-bit data is there, that we are going to divide into two 4-bit nibbles, right? So just execute it and cross check its output. Let us consider this design. So as defined, RS pin of LCD connected to P2.0, R/W bar connected to P2.1, and EN connected to P2.2, right? In this way, the necessary control pin connections that we did, now followed with, no doubt, total 8 data lines are there with me, but out of these 8 data lines, only 4 data lines are utilized for the command as well as data reception on this for this LCD, right? So these are D4, D5, D6 and D7, that is higher 4 data lines, data bits. Okay, so here the P3.4, P3.5, P3.6 and P3.7. Out of port P3, only higher 4 GPIO port pins are utilized for the data transmission, right? And the moment at which I am going to run the code, I am getting the output over here, say DKT, right? So this is my output. So again, as per the requirement, we can do the minor changes in our code, right? So suppose I am going to change its orientation. I am going to put here as a 83. Let us check what will happen. Now it is get set at first row first position. Instead of going to start from first row first position, it will start from first row fourth position when I am going to put the command as a 83, right? So in this way, DKTE-DEI, right? So again here, instead of 0E, suppose I am going to mention here as a 0F. What will happen? The way in which the cursor is blinking, simple, that will be get changed. Just check out this. Here it is with what? Vertical blink. And earlier, when I am going to put simple there as a 0E, it is with a horizontal blink here, right? So in this way, we can interface the LCD with 8051 microcontroller in 4-bit mode. When we are going to compare the 4-bit mode with the 8-bit mode, the biggest advantage of 4-bit mode is that instead of utilizing all the 8 GPIO port pins of a specific port or 8051 microcontroller, the same task can be done only by using the 4 GPIO port pins. And in order to do the same, right, how we are going to transfer the data? Whatever the data is there, first do the masking, means just extract out the upper 4 bit, and in order to do the same, the data bit we are going, or the actual command or the data that we are going to transfer, first that we are going to AND with F0. Because of that, the only 4 bits are retrieved, right? So that 4 bits are forwarded to port, associated port. Then just shift the same content, the data content, by 4 places towards left, and again do the masking with F0. That means do the ANDing with F0. So in this way we are going to extract out the data, means the data is represented into 4 bit data, right, and that is forwarded to the specified port, right. So in this way, in previous video session we had seen how to simply interface the LCD in 8-bit mode. However, this video session we discussed how to interface the LCD in 4-bit mode, right. So as per the requirement, we can again do the changes in the code. Okay, thank you.